All right, so in this video, I'm going to be showing how I completed the project for Professor Osbe. This should be the second project. We're putting geometries into the wind tunnel that we created. The geometry I'll be showing is going to be the sphere with the curve facing the entrance of the wind tunnel. So I already have them all done, but I'll do this one again so y'all can see. And I'll try to keep it quick. So you're just going to go back into sketching on the slate. And this is the wind tunnel we created last time. If you see the previous video, if you already did the project, you already know how to make this. I'm not going to do this perfectly just because I don't want to take forever. But basically, I'm just going to put the, I'm just going to make it easier, I'm just going to put this in the center, the first line. And then we're going to add some constraints. So I want this to be equal. So I'm just going to put a, if I can click it. Yeah. I don't love doing this on ANSYS because some of the stuff's a little annoying, but we can just add like a construction point and then do it the hard way so we can make it coincident with this line and with this line. And so now it should be right there. And then now we can make that point the midpoint. So it should be even, I think. Let me see. Yeah, it should be good. And we can check by stretching this out. Let me see. If I go to dimensions, and we want this to be, for this project, it was 10%. That's the blockage ratio. We want to be less than 10%. So V17, we'll just find it right here. Since the height of the chamber, the test section, is 6 inches, we're going to want this to be about 0.6 inches. And since we labeled it as midpoint, you'll see it stays right in the center. So that's great. And now we can just add a arc. And same thing here. I like to not put this perfect just because I prefer to make sure the constraints are proper. So we're just gonna make this point coincident with that point. And then now you know that it's a perfect half sphere. And since it's changed colors to blue, that means it is fully defined. So we can zoom out and look at it. That should be it. Now what we want to do is just generate, and you'll see it'll just punch out a hole in the wind tunnel. So now we have our half circle with a punched out hole, and that's all you need to do for the geometry part. Now, just a quick tip, if you guys are doing the airfoil, I would just do the whole thing in SolidWorks. It's easier. You can either go into concepts and add a surface, and then you can add the points. That would be if you want to do it in ANSYS, or in SolidWorks, you could just add the points there and then import it in. All right, so just close this. It should have saved, and then now we're going to go into mesh. Yeah, we'll just read the upstream data again. All right, so the mesh shouldn't be too bad to make once it loads, if it loads. I'm running this on a laptop, so it's a little slow. Honestly, it should be fine. We're just doing an example. So I'm gonna add, I have some of the old dots, so okay. So I didn't clear this out properly, but I guess I'll show you all with the last one that I'm missing. But basically I labeled everything. I tried to delete this, but I guess it didn't. I guess it still had it saved. But wind tunnel wall will be the outside. You don't want the inlet. You don't want the outlet. You just want the wall itself. This is the velocity inlet. Pressure outlets on the other side. And then you have fluid. I define that as everything that's inside of the wind tunnel, because we're going to need that later, at least for the way I did it. And the last thing we have to define that we haven't defined yet is, oops, we can go to edge selection, and we can select this one and this one. Just press Control to select two. Press the letter N on the keyboard and I'll pop that up, or you could right click and find it. And then we're just gonna call this, I like to call it semicircle. And yeah, right semicircle wall. So that one's labeled now, you can see. At this point, we can go into our mesh. I already have everything. Let me just delete this so we can struggle through it together. All right, so this part is kind of up to you. You can go as like, I guess as hardcore or as light as you want. If you really want to make it pretty nice, then you kind of want to define everything and you want to be like very specific with it. So for edge sizing, we're just going to select with the edge tool, we're going to select the, there you go. We're just going to apply those two edges into that section, geometry section. And then for, I'm just looking at what I did before, because I'm not going to redo everything. You might have to fiddle around with the numbers also if you want to change it, but you kind of, this edge sizing is important so you can see the boundary conditions that are around it. Well, I guess, yeah. So you can see like the actual effect of the fluid hitting the object that's in the wind tunnel. So this will help it like be way more visible, see what's going on. And then we're going to make the growth rate 1.02. Actually, I'll make it a little big. Oh no, I'll make it 1.02, but it might take a while to load, so we'll see. And then we'll do everything at once. So we'll insert now our method. So this method is going to be for the entire thing. So we're going to select the body. This, yeah, the method is going to be for the entire wind tunnel and how we're going to define it. And then we're going to apply the geometry after selecting it. And then we're just going to do triangles. All right, that's it for that one. And then we have to do inflation. So basically, the reason we're doing inflation, if I can find it, is because we want to get really close to both the object and the walls. You want to get, you want to be able to see what's going on as best as possible so you can see what's happening at the boundary layers. So if you don't do inflation, then it's going to be like a really rough image and you won't be able to see properly what's going on. So we're just going to select this face and then for boundary, we're going to select for the first one, we're going to select the outside of the wind tunnel walls. If you double click, you see it selects the whole thing, excluding this part. So that's perfect. And then you can press Control and double click again. Press apply, it should put 8 edges. So yeah, now you have everything defined. And then we're going to do first layer thickness. And again, for this kind of simulation, usually you want to play around till you get the proper values. That's what I did when I was making it. I kept adjusting it until I got it the way I wanted to. And this is the way that worked for me. So we should see if this works again, but it worked last time. And then we're going to do another inflation. This time we want it around the actual object. So for the second inflation, we're just going to select the face again. And then we're going to go down here and we're going to select 2 edges. So 1, 2, and we're going to apply those. And then similar idea, we're going to do first layer thickness. And then, you know, like I said, I was trial and error. So this one ended up, this is what I ended up going for, I guess you could say. And yeah. So now we're going to press generate, running zoom and this on the same time. So hopefully it doesn't crash. So it's at 5%. You can see down here. It's gonna take a second. Oh, one thing I wanted to mention actually, keeping it simple for this video, but ideally, what you want to do here is you don't want these rough edges for the transition in the wind tunnel. See those? So ideally, you could either just curve it a little bit, but if you want to do it properly, you can. NASA has like what's it called, like a flyer? I don't know, like a old document, and it shows you the ideal. I think it's a formula, like a cubic formula, and it's the ideal curvature for this section of the wind tunnel, and that'll give you like the most proper, the most efficient wind tunnel possible. So you guys do want to take the time to do that. I do recommend it. So now when we click mesh, it should show us what the mesh looks like. And yeah, I mean, that looks great. So let me show everybody. If you zoom in, you can see that here, they're pretty big. But as you get closer, you can always make them smaller, but it's fine for this. As you get closer, you can see how small we made them. And this is going to help get us a really nice image in the end. And then this is the edge sizing that we were defining. So you can see, you can get, you can get really close down and then be able to see those boundary conditions. So that's kind of how you want it. It's a really smooth transition for the most part. And same thing on these walls. So you want to be able to see the boundary conditions, the boundary layer, I mean, the walls. So you have the wall like this. This one's not as straight. You could work on it, but yeah. See, so it really is going to give us a pretty good image at the end. And you only need it at the walls. You don't need it on the inlet right here because there are no walls. So we're just going to save this. No, I don't think we need to save it like that. And once it loads, we can close it out. And that should be it for the mesh section. So now we can update our mesh. Usually I find that you have to do this first. I'll move this out of the way. That's fine. So it's updating the mesh. As soon as it's done, we can go to setup, and then this project is pretty short compared to the last one, I would say. So in setup, everything has changed, so we do want it to change. We're gonna go on my computer, I'm gonna go double precision, and then I think I have 4 solid processes. What's it called? Cores? Something like that. This is it. All right. And then I think there's only like 3 things we have to do in this section, so it should be done very shortly. All right. That's fine. It should be fine. So you can see our meshes here, and it looks great. And now we can start setting our boundary conditions and all that. So for the fluid, you just want to make sure that it's air, and then you can set your inlet velocity. I guess it just depends on the project requirements, but we can do like just to see, maybe like 3 meters per second. I don't remember what I did in the project. Let me see, where's the equations? Did I miss them? I just want to show everyone. Internal, I think that's it. No. No. Oh, models. Okay, so we turned energy off because we're not dealing with temperature, or well, we're not dealing with energy at all. Since this is like viscous and turbulent, I'm using K omega and SST. That's the model that I'm using for this project. That's what I wanted to show everyone. And we might as well define a report definition. So let me see. I don't want these. I want a new one. Let me delete this one. Okay, yes, that's fine. So for this project, you have to find the drag force on the object. This one part was a little tricky, so I'm just gonna show you how I did it. Not sure if it's the perfect way, but I'm gonna do it on the right semicircle wall because we want to see what the drag force on that object is. And make sure to drag force. Drag coefficient you're gonna have to calculate by yourself. So just take the drag force from ANSYS and then calculate by hand. And then yeah, we can just close that. And then for monitors, I like to plot the drag. So let me delete that. Delete that. So that way you can see when it when it converges. This one should be good, actually. I think that's the new one that we just defined. And then for initialization, I'm just gonna do standard initialization. This isn't like a complicated problem. Last time I ended up doing a hybrid, but that was unnecessary. It turns out I could have just run standard and it's way quicker. And then now we can just do run calculation. I'm just putting number of iterations to 10,000. We're not gonna reach it, but you can just put it high so it doesn't stop in the middle. And so now when you press calculate, it's going to run everything. And it should pull up our residuals and our drag plot. You can look at residuals for convergence, but honestly, I care a little more about the drag plot. So we're gonna let it run. And I don't remember what, you can choose when you want it to converge, like how small you want it. I think it's on like 0.001. So I'm not going to do the whole thing because that's gonna take a little while. But up here, you can see how many iterations it does. You don't have to set up the same way. You can put it in the bottom if it's comfortable, but yeah, you can see that it's almost converged already, it seems. The drag force. So we'll let it run for a couple more iterations and then we'll just stop it because just an example. But ideally, you want to make sure that it's pretty close to converging. You look at the residuals. I mean, there's not much change. They're still going up and down a little bit, but it's not a very big difference. These numbers are pretty small. So yeah, that's pretty flat. We're just gonna stop it right there around 30. And then, okay, so it already pulled up my contours, I guess, from before. Oh no, okay, they're gone. So I can show everyone how to do that. So you go into results, graphics, and then contours. I already set it, but you can check it out right here. So I made a new contour. I called it velocity. I put the contour for velocity magnitude. And then for the fluid, because I want to see what's going on inside the wind tunnels. That's why we named fluid earlier. We can compute it to get the max value and then just save and display. And you're going to see that it actually looks a little crazy. So, but not too bad. A little weirder than I remember, honestly. Velocity magnitude, yeah. It's a little wild. I thought it was a little smoother, but might just be forgetting. But yeah, that should look something like this. And then you can move these around wherever you want and then change their size so you can take a nice screenshot. And then for static pressure, did the exact same thing. This time went for a pressure contour called the static pressure. And then honestly, this should be fluid. And then we're just going to display. And then yeah, this one looks right. So basically, most of this wind tunnel is going to have a pretty similar bit of static pressure. And then here, where it gets turbulent, there's going to be a greater maybe the speed's a little too low. Maybe you could have put a higher velocity, but yeah, that's a little different than I remember. A little more static pressure than I expected, but yeah, there should be less static pressure on this area because the fluid should speed up in the wind tunnel. Let's see. Well, I guess mostly static pressure. It's a little weird though. It should be more of a mix, but I'm not sure exactly what happened. All right, so then the last step that we need to do is do streamlines. There's two ways to do it. So the one I end up doing, I think, something like this. This was just for the velocity streamline, so you can see what's going on. Again, checking just the fluid. I think there's something like 4 steps and 2. Do not run it with 500. 500 is the automatic one. It's most likely going to crash your computer. Even this one's going to take a while to load, but you'll see this is one way to do it. And then the other way, I don't quite remember at the moment. But yeah, so you can see here, it's really cool. This is the motion and it shows you the velocity also, but it's the motion of the fluid, what happens when it hits the plate. All right, and then the last thing to do is to go into our reports, and then it requests from you to get the drag force. So one way you can do it is you can go like this, and then you can just print it out right here. And so you have, you can see you have all your forces here, the viscous, the pressure forces, and your total forces. You don't use the coefficient. And then you can also write it to a file. So then you can also do that earlier. If you write it to a file earlier, then as you run it, it'll save every iteration. And so you can see the final value of the drag force after it converges. And that's the more proper way to do it rather than print it out. So you want to see the last value that was pulled. But yeah, that should basically be it for the project. Now I'm not going to save these edits. But that should be it. For the other pieces, just do the same thing. And then the only one that's different is the airfoil. I think somewhere here there's like I don't know, there's somewhere where you can do, maybe it's results, where you can find there's like a streamline function, then you can see the streamlines of the fluid flow. Yeah, I think it's here. Yeah. So let me try to pull it up real quick. Might be nice to look at. So this is our wind tunnel with our object inside. And then streamlines, call it streamline. Let's see if this works like I think, or not. Oh, insert streamline. Let's see if that works. I guess the answer is no. Oh, details. I think you can see that. Let's do the default details. Central parameter location list. Where's that? That work now? No. Location list is missing with streamline 1. Oh, I'm not sure actually. Equally straight samples. Surfaces. Oh. Antennas. Maybe wind tunnel. Let's see. Kind of want the whole thing. I don't want the wind tunnel wall. So yeah, I don't know if I did it properly. Velocity inlet. Maybe since that's where it comes from. Oh, I guess I did have to do it 3D. What if I do fluid here? Didn't change anything. All right. So I guess if you put it 3D, then you can see it. But yeah, this is one way to see the streamlines. And then it's also the same idea as the velocity path lines that I showed y'all before. But yeah, here you can see I could put more, I think, points, and it would be more defined. Let me see, because this whole area is empty. So you probably want to find like a sweet spot. Yeah, there you go. So the more you add, you get more, but this whole section is pretty empty. I guess that makes sense. That's what the fluid's flowing around it, but yeah.